So with these problems right here, this is going to be very similar to what you were doing yesterday, though with some of these you will keep it in fraction form and some of them you're going to put it in decimal form, kind of like what we were doing. And if you kind of between yesterday and today kind of forgot a little bit, we're going to run through it, so you're okay. The big difference between yesterday and today is that now we actually need to create our diagram, but this is going to give us some good practice because we're going to see word problems later with trigonometry where it's going to be just some kind of setup. It's almost like reading a little paragraph, and you need to figure out what to do from there. So this is some good practice to get us started on that line of thinking. So what I have is a triangle. Because it's trigonometry, I can tell you right away, it's going to be a 90-degree angle. Okay, let me get the pen. All right. Oh, I hate it when it does that. It likes to correct me. Okay, so there you go. That triangle looks a little better. So it's a right triangle. Actually, what I encourage you to do, and I'm going to pause real quick, I want you guys to go ahead and get out a piece of paper just to have a scratch paper because you'll need it when you do your work in a minute anyway. So hopefully everyone has something to write with. And what you want to do is you want to create this triangle. And we know there's going to be a 90-degree angle in this. It's going to be a right triangle. So as we go through, we just want to kind of label. So angle O is 90. So notice I haven't added any of the other things. Even though it says it's triangle MNO, I'm not labeling my sides or my corners yet. So anyways, at O, I'm going to label this vertex down here O, because now I know that is my 90-degree angle. Then there's going to be a side length that's ON that's 65 in length. Now it doesn't really matter which one we pick. And I didn't bother trying to draw this triangle accurately as far as the side lengths go. So I just drew a right triangle, and that's good enough for our purposes. So and I'll just call this N right here. The length from O to N, which is the next one here, is going to be 65. So I want to label that side length. All right, nothing earth-shattering here, but it is important to make sure you draw this triangle correctly. Now we have side length MO, which is 72. So I know it's going to connect to the O. If I put the M here, which it has to be there now, MO is going to be this left side of the triangle, and that's now 72, which means that my hypotenuse NM is going to be 97. Now here's the good thing. This obviously checks out because the hypotenuse should be the longest side. And we can see that 97 is definitely the longest side. So you will have to start these problems by creating your triangle and making sure you're taking just that extra little bit of time to make sure you're not just rushing through and creating the triangle incorrectly. But now we've got a triangle. This looks like something you might have had on yesterday's homework, right? So now the question is, what is the value of the tangent of angle M to the nearest hundredth? So let's first of all start by labeling, excuse me, labeling a reference angle. What's my reference angle here? So that's what I'm trying to find. So which angle should I mark on my page to be kind of tell myself this is the reference angle? M. Yeah, so it's whatever the trig ratio of this angle, so tangent of M. So that's my reference angle. So I'm going to go ahead and mark that. And from here, because you're drawing this on your piece of paper, now you can actually mark up and label which side is your hypotenuse, opposite, and adjacent. So which side is a hypotenuse? 65, 72, or 97? 97. There you go. The hypotenuse, and that's, I tend to do it that one first because it's a logical starting point for me. Okay, which between the remaining two is the opposite? Is it 65 or 72? 65. 65. Notice that's based on your reference angle. That changes, but because my angle goes like that, the opposite side is 65. So there we go. This is my opposite, which leaves this to be the adjacent side. highly, highly recommend that you are labeling this and don't try and just do this stuff in your head. Maybe you'll get to the point where you're comfortable with doing that, but at the beginning, certainly label it every time, because small mistakes, it doesn't mean you don't know what you're doing, but little mistakes happen all the time. Okay, and writing it out reduces the probability of getting one of those little mistakes. Okay, now we want to find the tangent of M. Now we want to remember, what does it mean to have the tangent of an angle? What ratio is that? This is where we're looking at that reference. We want to remember these three ratios. So what is tangent? Opposite over adjacent. So in our particular case, the tangent of M, what are those numbers going to be for opposite over adjacent?
65 over 72.
65 over 72. Now, there are going to be two types of problems that we have here. It's either going to ask you in this question prompt where the writing is, it's either going to say find the value of the tangent to the nearest hundredth, like it says here, or it's going to say what is the ratio of the sine of angle R, right? It might say something like that. So if it asks for the ratio, you would want to leave it in the simplest fraction possible. This is asking for the decimal. That makes it really nice and easy. You can just go ahead and do on your calculator 65 divided by 72. All right, so when we do that, 65 divided by 72, all right, I came up with that number. Does that mesh with what you guys got? Okay, yeah, it's pretty straightforward calculation. We should get that part right. So it's asking us to round to the nearest hundredth. This is where your rounding matters, okay? We did a short little lesson on rounding the other day, but I will say it's important to get your rounding correct. So with this, the hundredths place, that's right there. It's your second decimal. And to round this, you want to look at the one just to the right of it and determine if you're rounding up or down. Are we rounding up or down here? Down. So that's going to stay rounded to the nearest hundredth. My answer is 0.90. And there we go. That's all we need to plug in. So 0.90. Let's submit that answer and look at that. We did it well. Now it does run through and it shows us, you can see we got all these same values written down on our page and we rounded it right here. So once you have the triangle set up, it's really similar to what we did yesterday. And again, just to reiterate what these mean is that for this particular angle M, and we don't know the actual value of it, but for this, I can make this triangle bigger or smaller, but this ratio is going to stay constant. It's always going to be 0.9027 repeating for this particular angle M, whatever that degree measure happens to be. So that's good to know. And we can also think about it this way. The opposite side is about 90% the length of the adjacent side. And notice that right there. 65 is about 90% the length of 72. So that's kind of how we can think of it. So as we get that bigger, if this was 100 in length for OM, then that would be about 90 in length for ON. Okay, so hopefully just the whole philosophy behind trigonometry is making sense to some degree. So let me pull up a new problem. And here it's asking for the ratio. What ratio represents the cosine of angle L? And I want you guys to actually try and set this triangle up on your own. If you can get all the way through it and you can actually come up with the ratio, then that's good as well. But first of all, just focus on getting the triangle set up. All right, so I'm just gonna put the labels on my triangle and see if you guys, if your triangle looks the same as mine, that's all good. I'll put my M right here. So that makes that 5. Put the L right here, which makes this 12. And ML that is 13. So that's what my triangle looks like. And okay, hopefully everyone's matches up. And again, you got to make sure that it's the correct, like LN matches up. Anyways, you can do that part. So now we want to figure out, since it's saying which ratio represents the cosine of L. So we're really just finding this cosine of L. I don't know why it's been doing this, but whatever. So if we're finding the cosine of any angle, what is that ratio for cosine? Perfect. Thank you. Adjacent over hypotenuse, let's label our side. So my reference angle here is what? M, N, or L?
L.
L. And again, it's always whatever angle they tell you right here, that's your reference angle. And I'll tell you, it's never going to be the right angle. It's always going to be one of the two acute angles. So anyways, from here, go ahead and tell me the hypotenuse is which side? 13. The opposite is which side? And that means 12 is the adjacent. So now let's go ahead and set up the ratio. What's the ratio going to be? 12 over 13. That's adjacent over hypotenuse. Perfect. This is asking for a ratio, so keep it this way. Don't plug it in your calculator, get a decimal. And it's good to work with it both ways. Primarily, we're going to be dealing with decimals moving forward, but a ratio isn't a bad thing here. So 12 divided by 13. I just did the slash. I know in your calculator, they have the actual, sorry, on your iPad, they have a little calculator interface at the bottom. So you just hit division and it should bring that line up. So you can submit that. And we got it right. How about that? So that's essentially what you're doing today. We didn't really add anything new. It's just more practice and also practice with drawing the triangle when it's not given. So if you have any questions on this, you can stick around. We can go through more examples. If you feel like you're good to go, you can get to work on this, and I will see those of you online. I'll see you next week and see the rest of you in class.